So now in this video, we're going to do a quick test. I actually did this test, it worked, but in any case, I'm going to redo it right now for you. So I have a micro inverter here, right here. So it's a 600 watt micro inverter. We're not going to get anywhere near that. That's one of the things I didn't even know if it would go down to the wattage that I want to use, but it will. So we'll look at that later. So I think it has to be at least 15 volts for this to provide power. Now it doesn't really provide power. It helps provide power. It already needs a power source, so we're going to use just the regular grid. Actually, it's going to be powering like stuff in the house, but it has to recognize that there's the grid providing power. If the grid cuts power the way I'm doing this test, then this will also cut power so that it doesn't apply power to the grid and electrocute somebody working on it or something. So yeah, I think you need at least 15 volts from what I read before. I haven't tested that yet, before it will output power and help provide power. And up to like 32 volts. I believe though, if you go up above that, you may damage it. And so in any case, it's at 150 watt minimum, but I was able to provide power. So I have the power supply here. Again, it's important. I do not plug this into the grid like I normally do. I usually put it over here, and I don't usually move stuff. That's why we got all this dust. But instead I'm going to plug this into a power bank. So now I have my Engine Star portable power bank here. This is my weakest one. It's rated though for 150 amps, and actually let's wait to plug that in. I'm going to press the power button. You have to press it quick. If you hold it down, it doesn't turn on. To turn it off, you have to hold it down. So that's something that confused me. I pressed it before, and for some reason, like I thought you had to hold it till it turns on. It doesn't turn on. So you know, these things sometimes you kind of got to learn the rules to use them. So AC is not outputting right now. I got to press the button right there. Now we can set the AC, and I plug it in. So that's for this power supply there, and so there it turned on, and so yeah, we got the current up there. So that's at 24 volts. I believe the unit I'm using really, like, I could be wrong, but that's the max current I can get out of this power supply there. So we got like 48 watts of total power we can provide at this point. I think we can get higher though if I go to 15 volts. I'm not powering anything, so I don't have to be terribly careful. Okay, yeah, it's still, you know, in the range of like 45. So I think we'll just go to a 24 and stick with that. I'm not going to test the minimum that we can do. 24, 2 amps. We're pretty good right there. So now power supply is off right now. So if I accidentally short these or something, no big deal. Also, this turns off if you short circuit them. So I unscrewed these, and there's a couple little holes that we can go in there. You can also like plug banana plugs in there or whatever. You can see minus where the black is, red where plus where the red is. Of course, no surprise. And you got fuses in there as well. And we have a fan. So I'm guessing this is the bottom. I'm guessing it drags air into it. There's no vents in the top, I don't think. And okay, there are like little vents right there. There's also a power switch. So I'm actually going to turn that off right now while we do this. We do have a green and red light. I didn't know how well I'd be able to show that, but I can show that pretty well. So we'll look at that later. But in case, again, I have a limited power here, but I'm still going to plug it in. So let me get the, there they are, the alligator clips. And we'll just clip this one. There's a hole that will accept the alligator clip. We got them clipped in there. And again, this setup is just for very low power here. We're doing a demonstration. But in any case, I think this fan is probably going to draw air in. And if you, especially like using 600 watts or something, you probably want this pointing up right here, so that heat can go up if that's the direction that the fan's going. Of course, I always read like the literature and stuff. I didn't do that. I just wanted to point that out. I've seen people do videos where they said they fried these. But in case the power supply is turned off, I'm going to show you a little thing I did. So this has capacitors in it that needed to be pre-charged. So what I did was I kept it 24 volts. I dropped this down. Let's see how fast I can drop this down. There we go. Go to a 0. And so we have a 20 milliamps of current. That's what I previously set it to. And I don't know if the capacitor is charged or discharged now. We will turn the power on. And yeah, the current is limited. So now it is charging. So it's going to take time to charge that, but it's at 20 milliamps of current. So you're not going to get like a big spark or anything. This thing limited the current. That's an easy way to pre-charge the capacitor right there. And if you have like plugs or something, you want to attach like a battery to that's the same voltage that you got right now. Now you can attach it. You don't have to worry about a spark from the capacitors. They're pre-charged. So that's one way you can do it. Otherwise, you can like use resistors. So that comes up a lot. So now I removed the power supply from this. I also didn't have the current set up anyways. It was still down to like 20 milliamps. But yeah, I'm going to make sure the switch is in the off position. And then you plug this into the unit there. So now this is not to power this unit, and even when power is applied, it should be safe to touch these. The should not apply power until you plug it into some AC source, usually the grid in most cases, or if like your house is off grid, you have a different generator or something producing AC. This doesn't know the difference. But in any case, this is plugged into my other outlet. That's plugged into the grid. The green light is on right there, even though the overhead lamp is washing it out. And so yeah, you just plug it. Actually, I forgot a step. So you can like just plug that in. But I bought a meter right here, AC meter. And so yeah, I think this measures whether the power is powering a unit or whether that unit is pushing power back into the grid. I don't think it knows the difference. It just knows power is going one way or the other. And of course that's not going to go in. I forgot to take the plastic covers off. But I was expecting problems because actually that plugged in better than it did before. So we don't have that. Now, I didn't realize how much this covered. But in any case, if I was going to power a device, I would plug this into this unit and have the device plugged on the other end there instead of running it all the way through the rest of the wiring in the house. Try to keep as much of the power going that way to help the power going that way. Hopefully that makes sense. But yeah, this is being powered by the grid right now to light this up right here. But that's the time, and so I think that's once it's actually power's actually going. And it's a lot easier to see this in person. Maybe if I turn the lamp off. It's really easy to see in person, but it's not working out so well on camera. So just be aware of that. And so that's the wattage right there. And I think this would be, it says cost there. I don't think that's showing up. I think this will tell you, like if you got 15 cents per kilowatt hour that you pay for electricity, I think once you got 1,000 watts, like over an hour, however that adds up, then it will tell you like 15 cents or whatever. So I think this will tell you, how much your bill is going to be for you powering something. And I think it's also going to be how much money you would save. I haven't set it up, but I think it would tell you how much money you would save by the power that you push into it as well. This only pushes power in. It won't ever draw power out. So it wouldn't be adding up both the push and pull. But in any case, let's move on. So now I reattached the power supply right there. It's off actually right now, but there was a current showing up, which is a little disturbing. So now I'm turning it on. It's limited to 20 milliamps of current, and it took time for the voltage to rise. Now the voltage is the voltage we want, so I can bump up the current. So we didn't need to worry about high current during a charge. So right now the switch is off. That's when I'm going to plug this into the grid. And again, nothing should happen because it is turned off right now. So and that plugged in pretty good. For some reason, I can't remember which one. One of these wasn't plugging in too good anymore. But yeah, we have 0 watts right now. And this is why we got stuff, such weird angles and stuff in my limited space right here. Because I wanted to be able to see these LEDs. So now I'm going to turn it on. I know this isn't showing up on camera, but it still says 0 watts right there. So yeah, we had the red air. Now I think it's like sensing the grid right there. And I can see wattage going up right now, and the timer set. So I know you can't see that. But yeah, now it was in about 20. Now it's up 35 and dropped down like 25 or whatever. It's kind of bouncing around right there. But the main takeaway is that this is providing power to, technically the grid, but I have the TV on that by itself, is using up more power than we got there. So technically this is probably powering first off this lamp here, if it has more power to provide. The TV, we got, probably about 40 watts. And I did something, oh, the display just backlight turned off. I can still see the numbers. So here you can actually see this pretty good. Plus I still had the protective screen on there, so maybe we could have seen it while it was backlit with that protective screen. And I think that's just kind of glue residue, but in any case, you can see this about as good as I can right now. So yeah, the unit here is providing about 30 watts of power. It looks like sometimes lower than 30. There we go, and sometimes a little more. So looks like we're getting about 35 watts. Let me check the power supply, or the power bank. That's going up from like 50, maximum, and then sometimes down into like 30 something. So maybe it's like 45 watts that it is providing. And then so maybe we're losing like 10 watts in the process. Maybe the power supply, because remember, I can't use the grid to provide power to this, because we're going back to the grid. At some point maybe wires will get crossed or something. We'll have a short circuit, something would fry, and that's what I'm guessing. I don't want to test that. I hope nobody else does either. But yeah, this is probably powering like this lamp here. TV's on, and my laptop's on, everything. And so none of this is making back to the grid, but it is helping the grid. If the grid went down, then this should turn off because it's feeding into the grid. But instead of the grid, if I was using a something else that generates AC, either a generator or an alternator or something, then we would have inverter. I mean, like a regular inverter. This just like senses the AC and then helps out. Remember that. Whereas a regular inverter provides power. You can't provide a regular inverter to an AC outlet, a grid tied outlet, because they won't line up to when they're providing power. So when one wire is positive, the other one might be negative. That's a short circuit. Whereas they both have to be positive and then negative at the same time as they flip back and forth, each wire. Hopefully that makes sense. But yeah, I didn't know how this demonstration would go. I think it did really well. It's not near as great as other people that made the same videos, but this is my first grid tied inverter right here, micro inverter. And so I was trying to work on making something more impressive, but I don't have a bunch of money to just buy that at the moment, so I'm not going to do that now. But hopefully you still enjoy it. So that's it for this video. Thanks for watching. Make sure you check out one of the other videos. And I am actually going to flip the switch for the inverter there to stop providing power right there, first thing. And then I'm going to dismantle this like I mantled it, but in the opposite order. So thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.